In this video, we're talking about two-way data and how it's different than one-way data. So let's just quickly review what we mean by one-way data, which we've already covered previously. So something like this would be a one-way data table where we have the individuals, which are the months in this particular case, down the left-hand side, and then the single variable for those individuals down the right-hand side where the variable is revenue. We can also describe individuals and variables as dependent and independent variables. So in this case, the month is the independent variable, and the revenue is the dependent variable because the revenue depends on the month. If I asked you how much revenue did we make, you would ask me in what month, because the revenue is dependent on the month. The amount of revenue that we have made depends on the month that we're talking about. So previously we had referred to the month as the individual and revenue as the variable, but we can also call the month the independent variable and the revenue the dependent variable. And we also already know how to graph data in a one-way table. So for example, if we made a bar graph for this data, it would look something like this. We can see that the smallest value that we have in the table is the revenue for the month of February, just under $15,000. And the largest revenue figure that we have is for the month of November at just over $48,000. So we'd want to set up our axis here from 0 up to $50,000 so that we can capture this $48,000. And then we would just graph the revenue for each month. So for January, we had about $28,000. So you see that comes up to a little over the $25,000 mark. Here's February at just under 15. So that comes up just over the $12,500 mark, and we plot those bars all the way to December. We've already done all that, and we know how to handle one-way data. So now, how is two-way data different than one-way data? Well, this here is actually a table that we're saying displays the revenue earned by an artist in each month of the year. But we're saying that this artist has been in business from 2014 through 2017. So he's been in business 2014, 15, 16, and 17, 4 years total. And in order to get the data in this table, what we actually did was we took his revenue from all 4 years in January. So January of 2014, January of 2015, 2016, and 2017, all 4 months of January, added that revenue all together to get one figure for January. And we did the same thing for February. We took all 4 Februaries, added them together, got a revenue total, and therefore we have a one-way data chart and we were able to plot that. But of course, if this is actually our real-life scenario, well, this is a great summary table to see maybe which month the artist does best in. So for example, we can see that November is clearly his best month, January is his second best month, etc. We really lose a lot of detail. We have no detail that shows the artist's revenue in 2014, 15, 16, or 17. It's all lumped together. So we can't tell, for instance, if the artist's business is declining, if he's making less money year after year after year, or if his business is doing well. Maybe he's made more money every year. We have no visibility into that because we don't have the breakdown here by years. It's just a one-way summary table. The way that we fix that is by creating a two-way table instead to show the detail by year. So here's what that might look like. If we created a two-way table for the artist's revenue and we still have the months down the left-hand side, but now instead of just showing a total figure for each month, we've broken it out by year. So we have detailed data for 2014, 2015, 2016, and 2017. And this is a two-way table, and this is the difference between one-way data and two-way data. With one-way data, we just have the individuals and then the variables here. And the dependent variable only depends on one thing. Again, going back to the how many questions do you have to ask idea, if I ask you, how much revenue did we make? You only need to ask me one question. For which month? If I then tell you July, you can tell me right away, oh, $17,990. All you need to know is the month. You only need to answer one question in order to figure out which value of the dependent variable you're interested in. But with two-way data, you need to answer two questions. So in the body of the chart here, we have revenue. And if I ask you, how much revenue did we make? You now have to ask me two questions, which is why it's called two-way data instead of one-way data. Not only do you have to ask me for which month, but you also have to ask me for which year, because you need to know that I'm actually interested in April of 2016 in order to give me a figure. You need to know the month and the year. You have to ask two questions, so it's two-way data. So the dependent variable of revenue in the body of the chart depends on two independent variables, both the month and the year. Two-way data tables get even more interesting when we show totals, if possible, by row and by column. So we can add in here, we can replace this two-way data table with one where we show the total by row here on the right side and the total by column here on the bottom. Here's what we're doing. If I take all of the revenue for 2014 and I add it up, I get a figure of $8,980. That tells me how much the artist made in the year 2014. Then I can look and see how much he made in 2015, 16, and 17. Now I actually have some detail because I can see that his business is growing. In fact, it's growing significantly. I can see that his revenue in 2014 was only about $9,000, but then in 2015 it increased to $31,000, then about $72,000, and then a little over $161,000. I had no insight or no visibility into that in the one-way table, but breaking the data apart into a two-way table allows me to see that growth year over year. In addition to that, on the right-hand side, I have totals by month. These represent the sum of each row, so 28,361 is the sum of January across all 4 years, which makes sense because these numbers match the data in my one-way table. Notice here January is also 28,361, like it is over here, 28,361. So this gives me the total for all of January, 14,744 is for all of February, 19,407 is for all of March, etc. And this gives me insight into the best month for the artist historically. Again, I can see that November is by far his best month, whereas February and April are his worst months historically. And that's one of the reasons a two-way table is so helpful. I get visibility into both the year and the month because I can analyze the data and sum the data both ways. I can also see things like the historical best month ever. I can see that it was November of 2017 at just over $26,000. This is the largest figure in the body of the table, so I know that the artist made more in November of 2017 than he did in any other month. The least he ever made was $254, which was the very first month he was ever in business, January of 2014. And I could look and see the very best month for any particular year, or I could see the very worst month for any particular year. I also have data where now I could, for example, create a line graph of just his data for 2014, or just his data for 2016, or just his data for August year over year. So you can see how the two-way table becomes really powerful. Let's go ahead and do a side-by-side comparison bar graph to illustrate the data in the two-way table. So we want to start with our axes as we normally do, and then we're going to need values along the vertical axis that encompass the lowest possible value of 254 and the highest possible value of 26,000. So for example, we might do axes like this, starting at 0, so we can graph 254, and going all the way up to 30,000, so that we can graph 26,000. We could pick other increments, but these are just the ones that we picked. And then, of course, we want to put the months across the bottom to show all of the data in the table. Now from here, we could go in and graph the data for 2014, and that might look something like this. Obviously, the largest value in 2014 is just under $2,400, so that's going to be about a third of the way up to $7,500. Everything else is going to be a little shorter. Then we could go in and graph the data for 2015, and this will start to get a little clearer because the values get bigger. So in 2015, our data would look like this. And now we can quickly tell that the artist did better in every single month of 2015 than he did in each month of 2014. So for example, January 2015 was better than January 2014, and February 2015 was better than February 2014, etc. So every single month he did better year over year. If we add in the data for 2016, we get a plot that looks like this, and then we add in the data for 2017, and now we see a full picture of the two-way data, or the two-way data table. This is a comparison bar graph, but we could have also done a comparison line graph. But no matter how you graph it, we can see in the same way that we analyze the data in the table, we can analyze the data visually in the bar graph. So for example, we can focus in on just January, and we can see that the artist made a very small amount of money, then a little bit more, and then maybe something around $10,000 or so, and then maybe something a little over $15,000 in 2014, 15, 16, and 17 respectively in January. We could analyze February individually or March individually, but we could also look across years. For example, if we take the light blue, which represents 2016, we can see that he got a strong start in January, pretty well in February and March, and then much slower in April, May, June, slowly building in July, August, September, and then as we've seen in the table, a really strong November before closing out the year in December. Or we could look at his 2017 data in the dark blue, and we could see that he had his best month ever, every month in 2017. So we can get a lot of information from a comparison bar chart that we constructed from a two-way table. And as usual, especially when you have multiple data sets graphed in the same chart, it's helpful to include a legend. So we could include something like this that indicates by color which data set represents 2014, 2015, 2016, and 2017. So either one of these, the one-way data table and the two-way data table, both are acceptable, and they certainly both have their benefits. For example, the one-way table is a really nice, simple view of revenue by month. We don't have all this detail that we have to deal with. It sort of simplifies things, makes it easy to see revenue by month. So if that's all we're interested in, a one-way table might be just fine. There are lots of instances where we don't need the detail of a two-way table. But as you can see, a two-way table can certainly provide a much higher level of detail and give us much more visibility and insight into the data itself.